This is enhanced ACT25MC1. They have added an additional 5 minutes to the science section and kept the number of questions the same. So if you break down the timing per question, you now have exactly a minute because it's 40 minutes for 40 questions. It was on the classic format ACT that's been in place for several years now, 35 minutes for 40 questions, which would give you 7/8 of a minute per question, which is 52.5 seconds. Does the extra 5 minutes help? Of course it helps. It gives you a little bit of a margin. Does it make it easy to finish in time? No. You still have to really move to have any extra time and push all the way through on the ACT Science. I'm going to try to talk through the entire section now. Before we dive in, they've kept it as 7 passages, 6 of which have charts and graphs in the setup. There'll only be one that's words only. For that one, you have to read the words and understand the basic idea first. For all of the other passages that have charts and graphs, you're better off going to the first question first and then looking back at the words only as needed. Okay, let's go for it. So, because this has charts and graphs, I'm going to skip right to the first question. Based on Table 2, which of the following ratios best represents the number of times behavior 2 was displayed in habitat X compared to the number of times behavior 2 was displayed in habitat Y? Table 2, behavior 2, X and Y. Table 2, behavior 2, X and Y is 3 to 6, which is 1 to 2. Which of the following observations for brown anoles was or were the same in both habitats Y and Z? Brown anoles, average perching height. Perching height, so what is shown by which chart? Oh, so figure 1 shows perching height. For brown anoles in habitats Y and Z, brown anole is the circular, so these are the same. So yes. The number of times behavior 4 was displayed. Behavior 4 for brown anoles. So your instinct is to look at this Y and Z. Well, those are not the same, but are those for brown anoles? Yeah, brown anoles displayed behavior, so that's definitely not number of times, so that's gone. So this is gone, and this is gone. Well, it must just be 1, but you could confirm that this is not the same if you wanted to. Average display time for behavior 5 is this for the brown. So yeah, so these are not the same, so no. Okay. Based on Table 3, how many display times were measured for behavior 5 in habitat Z? How many display times were measured for behavior 5 in habitat Z? Table 3 lists for the anole species in a habitat the average display time for behavior 5. But how many anole species are there? Let's look at the options again. So, how many display times were measured? Oh, does it not say? Let's see. For the anole species in a habitat, the average display time for behavior 5. Ah, but it doesn't tell you how many actual critters there are for each type. It's just telling you an average. Yeah, so if you're, and there's some sort of a reptile, so it could have been 10 or 100 or 1,000 or 1,000,000, and they're just averaging it. So I believe it's actually just cannot be determined. I don't like that question. Okay. Based on figure 1, for green anoles, the difference in average perching height between habitat X and habitat Y was closest to which of the following? Figure 1 for green between X and Y. So that's the squares here and here. I would have just interpolated and approximated as 0.9 and 1.6, which should be 0.7, right? A student claimed that anoles are endotherms. Which of the following explains why this claim is incorrect? So I don't believe it mentions the word endotherm. What does it tell you here? 2 species of reptile behave differently when species are... Yeah, but it doesn't say anything about endotherms or regulation of body temperature. So this is actually one of the relatively rare real-world science questions where they expect you to know. They expect you to know that reptiles, which is all that it says, right? Reptiles are cold-blooded, as in they rely on the atmosphere to heat their bodies. Now, which answer choice is that? Amphibians and animals are well, it says that they're reptiles. First of all, it literally says they're reptiles, so these are just gone. Reptiles and primarily generate heat from internal metabolic processes to maintain body temperature. No, that's what a mammal does. That's what humans and other mammals do. Reptiles and primarily absorb heat from the surrounding environment to maintain body temperature. Yes, that's the correct answer. You're just expected to know that or know the basic idea. Okay, this is the words only one. So this is a chart and a graph, but the chart and the graph is not in the setup. That's in the actual question. So you basically have to read these. Coastline of Antarctica consists of many ice shelves. Sure, many of these ice shelves are melting, causing them to calve, break off. Large pieces known as icebergs. 4 students each explain iceberg calving, okay? Antarctic ice shelves melt due to warming of the air above the surface of the ice during the summer. So I'm going to highlight the main idea. They melt because of that. And then I'm going to jump to the next student. Student 1 is correct that an increase in air temperature during the summer leads to surface ice melting and water pooling, causing fractures to form in the ice. However, the action of the melt water alone is insufficient to produce fractures deep enough to cause calving. When the air temperature lowers at the beginning of winter, falling snow accumulates in the fractures, increasing the pressure. After a large snowfall, calving can occur. So this is basically the air temp and snow. Whereas person 1 says it's the air temp melting surface ice. Okay, student 3. Antarctic ice shelves melt only from below. During the summer, ocean currents circulate water that is just above freezing into and out of the basal cavity, the area underneath the ice shelf, causing ice within the cavity to melt for every... Sure. Okay, so this is melt from below. Student 4. The warmer water circulated by ocean currents melts the ice shelf as described by student 3. However, calving cannot occur from this process alone. So it's melt from below and something else. Snow accumulates on the surface of the ice each winter, but each following summer, warm air leads to the melting and compaction of the snow. Compaction lowers the surface of the ice shelf. So this is plus snow. I'm just going to leave it as plus snow. Okay. Which of the following diagrams best shows the location of the basal cavity as described by student 3? During the summer, ocean currents circulate water that is just above freezing into and out of the basal cavity, the area underneath an ice shelf. So the basal cavity has to be underneath the ice shelf. So it's definitely not this. It's not on the water. No, it's just underneath the ice shelf here, right? Suppose that the air temperature along the Antarctic coastline is never warmer than negative 10 degrees Celsius and that the atmospheric pressure is always exactly 1 atmosphere. Does this information support the description given by student 1? It's the air temperature along the Antarctic coastline is never warmer than -10 for student 1. Student 1 says, warming of the air above the surface of the ice during the summer. When the air temperature increases, the surface ice melts. But of course, water melts at 0 degrees Celsius. So if it was never warmer than this below freezing, then it could never actually melt. So does it support the description given by student 1? Well, no, obviously not, because ice cannot melt at those temperatures. Sure. Based on the description of the icebergs that are calved along the coastline of Antarctica, do the icebergs sink or float? Interesting. Well, we know that icebergs float, but where does it say that? Thick sheets of ice that extend from a landmass cause them to calve. Yeah, it shows. Sink. They are more dense than ocean. Oh, well, of course we know that they float. So, and things that float in general are less dense than ocean water. Which of students 1 and 4 have either implied that the process involved in iceberg calving will take more than 1 year to result in the formation of an iceberg? More than 1 year for students 1 and 4. 1 and 4. Here we go. Over many summers. So yes, that implies that it's more than 1 year. And then student 4, yeah, several summer-winter cycles. So it's both of them imply that it takes more than 1 year. In regard to the seasons involved in iceberg calving, how does student 2's description differ from student 3's description? Student 2 indicated that the seasons involved in the calving. Student 2 says beginning of winter and also during the summer. So student 2 is saying it's summer and winter. What is student 3 saying? Summer. I think student 3 is mentioning only summer. So, student 2 is saying summer and winter. So, student 2 indicated that summer and winter are involved, whereas student 3 indicated that only summer is involved, I believe. Summer and winter are involved. No. Only winter is involved. Yeah, student 3 says only summer, right? Yes. Which of students 2, 3, and 4 agree or agrees with student 1 that some form of melting occurs on the ice shelf surface? Well, I thought student 2 agreed surface ice melting, so yes to 2. And then 3 said only from below, so not on the surface. But what about person 4? Yeah, it melts as described in student 3, which is from below. However, calving cannot occur from this process alone. Snow accumulates on the surface, but each following summer, warm air leads to the melting and compaction of the snow. So there actually is some that's on the surface also for 4. So it's 4 and 2. Okay, because we have charts and graphs, we can go right to the charts, right to the first question and point back to the charts and graphs. Which of the following statements about the relationship between the number of AP per tank and the average SGR is consistent with the results of experiment 2? Experiment 2 is this. Average SGR is this. AP per tank. Well, stocking density of the fish per liter. So as long as the tank was the same, the stocking density is effectively proportional to how many fish there are in the tank. So having more fish is going downward toward the lower end of the graph for stocking density, and this is decrease, decrease, decrease. So as the number of AP per tank increased, the average SGR is decreased only. Following table gives the percent protein in each of the 4 diets. Okay, which of the following statements about the percent protein in each diet and the average SGR is consistent with the data shown in the table and the results of experiment 1? Experiment 1 is this, an average SGR. I'm just going to say that this is the low and this is the high. Okay, so the diet that resulted in the highest SGR also had the highest percent protein. Well, the highest was S as in Sam. Was that the highest protein here? No. Highest protein had the lowest percent. Is that? No, it's not that either. The one that had the lowest, which is Q as in quicksand, had the lowest, had the highest. Yeah, that's this. Based on the results of experiment 1, if experiment 2 were repeated except that all the AP were fed diet R, would the average SGR more likely have been lower or higher for each group? Experiment 2 repeated using diet R. So experiment 2 tells you procedures for experiment 1 were repeated except that each was kept at different stock density and all fish were fed diet T as in Thomas. So all of these over here are diet T. So if you gave them R instead of T, let me do this in pink. So instead of T, if you gave them R, well, that means that they grow more, right? The SGR is how much they grow in terms of percent per day. So it would be 0.4 instead of 0.35. Would more likely have been higher, lower or higher. So it would be higher because 0.4 is more than 0.35. So higher had yeah, it's this much higher, right? Because it's the difference between 0.4 and 0.35. Suppose that in the experiments 1 gram of food were added to each tank at each feeding. A total of how many grams of food would have been placed into an individual tank each day? 1 gram for each tank at each feeding is how much total into each tank per day. It must say that in the words, right? I'm going to go all the way back to here. Each of 12 identical 15-liter tanks received 10 liters of seawater having a salinity of 33, temp 27, pH of 8.2. Salinity, temperature, and pH were kept constant over the course of the experiment. A pure of similar lengths, were equally distributed among the tanks as stocking density of 1 fish per liter. The tanks were divided equally into 4 groups, okay? During 4 months, each group was fed a different diet. Each group was fed the same mass of food. Oh, here we go. 3 times daily. Each group was fed the same mass of food 3 times daily. So the fish in the tank get fed 3 times daily, which just is the answer, right? Because so 1 gram, yeah, makes it 3 grams. How many AP were placed in each of the tanks in experiment 1? So it must have to do with these numbers. It's a 15-liter tank that received 10 liters of seawater, and then they're stocked at a density of 1 fish per liter. So the tank has a volume of 15 liters, but they don't fill it up all the way. They only fill it up 2/3 of the way. So it's this and this is 10 fish per tank. Which of the following was a dependent variable? So you expected to know this from how science works. So I always say that dependent means it depends on how you set it up. So independent is what you deliberately set up, what you deliberately manipulate, and then dependent is effectively what you're measuring, what the outcome is. So it must be the growth rate, right? That's what you're actually determining what happens. This you deliberately set up, this you deliberately set up, and this you deliberately set up. Okay, because it has charts and graphs, I'm going to go right to the first question. Which of the samples in experiment 1 was most likely intended as a control for the concentration of vitamin C? Well, whatever the control is, it's where you don't manipulate anything. It's just the default with nothing. So in experiment 1, well, it seems like it has to be this instinctively, but let's see. Yeah, incubation time. Yeah, it must be. So, I see. So incubation time at 88 degrees C. So that's if you don't incubate it at all. So if the thing is just sitting there before you do anything to heat it up or whatever, it must be just sample 1. Based on the results of experiment 2, which of the following incubation times would most likely have produced a tomato mixture with a lycopene concentration between 5 milligrams per gram tomato and 6 milligrams per gram tomato? I'm going to guess that this is interpolation. Experiment 2 giving you something between, so it's lycopene concentration, make sure you're looking at the correct graph, between 5 and 6. Well, that means you'd have to be somewhere out here, right? So between 5 and 6 has to be something between sample, well, it's either sample 3 or sample 4, so it's something somewhere in this range, unless I'm missing something. So something 15 to 30, sure, must just be 20 minutes. Okay. A student claimed that heating tomatoes decreases the concentration of nutrients present. This claim is consistent with the results shown for which of vitamin C and lycopene, if either. So vitamin C and lycopene are nutrients. So does heating them decrease the concentration? So is it correct that the hotter you get, so as you go rightward, does the concentration go down? So I would say yes to this and then no to this. So it's yes for vitamin C and no for lycopene. So is vitamin C. Assume that in the experiments, the water bath contained pure water at standard atmospheric pressure, 1 atmosphere, while the bags containing the samples were being incubated. Was the water in the water bath most likely boiling? Yes, the incubation temperature was less than the boiling point of water. The bags of this were being incubation. Oh, I see what they're saying. So, yeah, but the incubation temperature is 88 degrees Celsius. So you're expected to know in the real world, water boils at 100 degrees Celsius. So obviously the incubation temperature is below the boiling point of water. So the water would not have been boiling. So In experiment 1, how many of the samples had a vitamin C concentration of less than 1, whatever that is, per gram of tomato? Experiment 1, how many samples of the vitamin C had a vitamin C concentration of less than 1? Well, am I missing something, or isn't that all 4 of them, right? Because this would be 0.9 and this would be 1. So I would have said it was all 4 of them, unless I'm missing something. Had a vitamin C concentration of 1. Yeah, it's all 4 of them, right? It almost seems like a trick question, but it's not really. Consider the following procedures performed in experiment 2 for sample 2. Frozen, incubated water bath, sample and solvent mixture was filtered. These procedures were performed in what order? In experiment 2 for sample 2. Experiment 2 says experiment 1 was repeated, except that in step 3, the filtered liquid was analyzed to determine the lycopene concentration, milligrams per gram of tomato. So I think what they're saying is, experiment 2, the filtering step at the end, they look at some other thing, but it points back to all of this. So each sample was placed in a separate plastic bag and the bags were sealed. The bag containing sample 1 was immediately frozen at negative 40 degrees C. Yeah, but it's not that, because that's sample 1. We're looking for sample 2. The bags containing samples 2 to 4 were each incubated in a water bath at 88 degrees C. So incubation happens, and then the freezing happens. So incubate, then freeze, then 2 days later, it does the filtering. And for experiment 2, they just change what you look for when you're filtering. But it's incubate, freeze, filter, which is 2, 1, 3. Okay, because it has charts and graphs, you jump right to it. A linear region of the graph is a range of data that can be approximated with a straight line. Based on figure 1, for alloy Q initially at a temperature of 550, which of the following ranges of F best represents a linear region? Alloy Q at 550, which is the dashed line for alloy Q, and this is the only dash. So I would have said it was from something like, is there an option that's, 25 to 45? Let's see. Oh, I see. Well, so everything's in terms of 10 to the 7th, of course. I don't think it's 0 to 7. No. Sorry, 0 and 10. It's definitely not 0 and 10. It's not this, because that's not a straight line. Okay. 10 to 20, no. Is it? It's not 20 to 30. Is it 30 to 40? Oh, yeah, that must be that. Oh, I see. So this is a straight line. Okay. Consider the two trends shown for alloy Q initially at the temperatures of 280 and 550 from 40 through 48. If these lines would continue along the same trend, at which the following values of F would the average crystal length most likely be the same? So this is extrapolation to see where extrapolated lines cross. They're saying from 40 to the end, effectively. So it's like going like this and this, which obviously would cross here, and just ballpark, it's got to be 60, right? Yeah. Based on figure 1, which of the following combinations of values for initial temperature and F would produce the shortest average crystal length in an ingot of alloy Q? The shortest average crystal length. So average crystal length is this. Yeah. The shortest, well, it's the one that has the high temperature and the lowest F. So it's whatever that is. The high temperature and the lowest F is just this, right? 550, and the 10 would be... Oh, or did I mess that up? Oh, maybe they plunked it in and it's not quite that obvious because that line, the curve fluctuates up and down. is it the 10 or the 40 at the 550? Well, the 10 is here and the 40 is here. It's actually the 40. Okay, that's really tricky. It's actually the 40. I misspoke and did that too quickly. So this is actually J as in John here. Tricky. Following table lists the mass of silicon in 50-gram samples of 4 different alloys, one of which is alloy Q. Given the composition of alloy Q, which sample is most likely alloy Q? The mass of silicon in 50-gram samples. Well, this has to do with the percent composition or density. So percent by mass. It's okay. So percent by mass, and this is the mass in 50 grams of alloy Q. Percent by mass in alloy Q of silicon. Okay, here we go. Okay, so silicon is 10.8%. 10.8%, which is about 1/10. So if 50 grams, it would be about 1/10, which is about 5, right? Or a little bit more than 5, yeah. So it's got to be Z as in zebra, yeah. Based on table 1, if an ingot of alloy Q had a mass of 200 grams, that ingot would contain what mass of magnesium? If it was 200 grams, well, this is percentage composition again. So magnesium is 0.22%. 0.22%, which I'm going to think of as it's about 1/5 of 1/100th, right? It's about 1/5 of 1%. So 1% of 200 would be 2, and it's about 1/5 of 2, which is about 0.4, which is G's and girl. Okay, because it has charts and graphs, you can jump right to the first question. Based on the results of the studies, from which of the 5 leachates was the greatest percent of DOC adsorbed by CM1, CM2, and CM3, respectively? Percent of leachate adsorbed by CM1. So this is CM1, CM2, and CM3. The greatest percent, I would have said it was pine for 1, magnolia for 2, and magnolia for 3. Pine, magnolia, magnolia. Based on the results of study 3, the percent of leachate DOC absorbed by CM3 averaged across the 5 types of leaves is closest to which of the following? Study 3, percent absorbed across the 5 types. I'm just going to do the math, right? So 35 plus 50 plus, call it 30, call it 55, call it 35 is 85, 115, 170, 205 divided by 5 is 41. Yeah. Is the statement CM2 adsorbed a greater percent of the DOC in the maple leachate than did CM3, supported by the results of studies 2 and 3? So the CM2 and CM3 for the maple. CM2 for the maple is, 22. And then is this one. I'm sorry. CM2 here for the maple is 17, and CM3 for the maple is 35. Okay, so is it correct that CM2 absorbed more? No, it's the other way around. No, CM2 absorbed 7. I thought it was 17 because I accidentally looked at the wrong thing really quickly. It's more like, God, I said it wrong again. Sorry, I'm embarrassed. I said it wrong. It's designed to deceive you. Wait, this one is a 22. This one is a 7, right? It's below 10. So CM2 is a 7, and the other one is a 35. CM2 absorbs 7, the other is 35. Yeah, okay. Based on the results of the studies, which of the three clay minerals, if any, reduced the DOC in the oak leachate by more than 50%? Reduced it by more than 50%. Well, I think what they're saying is adsorbed. Adsorbed is how much it gets reduced, I think, but I'm going to look back at the word. So adsorbed by is becomes adhered to the surface of clay mineral particles that are suspended. So in order to reduce it by more than 50%, then more than 50% has to be adsorbed. So it's asking effectively how many of the three for the oak are higher than 50. So oak is 30, so no, and then 20 something, so no, and then that one seems like it's exactly 50. So more than 50%. So reduced by, well, no, right? So I would say it's none of them. It looks like the third one is exactly 50, but that doesn't count as more than 50. But either way, there's no option for CM3 only, so it's got to be none. Is a mixture of any one of the leachates and any one of the clay minerals properly considered a solution? Let's look at their answer choice. Yes, because clay mineral particles are dissolved, are not dissolved, are dissolved, are not dissolved. Okay, a solution. So do they completely dissolve? Let's see. Becomes adhered to the surface of clay mineral particles that are suspended in the water. So if the clay mineral particles are suspended in the water means they're still floating in the water rather than having been thoroughly mixed in. So they're not dissolved. So it's definitely a not dissolved, which means it's not a solution. So I would say, is it a solution? No, it's a mixture, right? So no, because they're not dissolved. In lake water, DOC is broken down into simpler compounds by electromagnetic energy in the visible wavelength range. Electromagnetic energy in the visible wavelength range, known in the real world as light. What action was taken in the studies to prevent this process from occurring? So how do you prevent light from doing what it does? Well, it has to be something about being in the dark, right? Well, it's not the filtered. It's got to be the in the darks. Each mixture of leaves and filtered lake water was placed in the dark. Each mixture of filtrate and clay mineral was placed in the dark. I forget. Let's look back at the setup for what they actually put in the dark. The filtered lake water. The mixture was then placed in the dark. So 5-liter volume of lake water was filtered to remove all solid particles. Following procedures were performed for each type of leaf. 100-gram sample of the leaves was mixed with a 1-liter volume of the filtered lake water. The mixture of the leaf and the water is placed in the dark, which isn't that just... Yeah, is F. Okay. Last passage which has charts and graphs, so I'm going to go right to it. Consider the current shown in the emitter in Figure 1. Based on the results of Experiment 2, when this current was measured, what was the relative intensity of the light? The emitter in Figure 1. That must be the 19.8 that they're referring to. And then, based on the results of Experiment 2, I must be pointing to this, right? So they expect that number to jump out at you to the 50%. What aspect of the experimental setup was held constant in Experiment 2, but not in Experiment 1? Held constant in Experiment 2, as in an independent variable. So in Experiment 2, except without a filter, the current were measured as the intensity of the light. Okay, so intensity of the light was varied. Whereas in Experiment 1, procedure was repeated with each of 4 additional filters. But in Experiment 2, there was no filter at all. It says without a filter. So the thing that was held constant is what has to be the color of light, right? Because don't the filters change the color of light? Let's see. Yeah. Based on experiment 1, are the particles ejected from the metal plate moving forward toward the electrode or away from the electrode? And are those particles positively charged or negatively charged? On figure 1, well, the arrow here shows that the particles are moving toward the electrode. So it's a toward, and they expect you to understand that electrons are negative. So I would say toward and negative. Based on the equation in the passage and the results of experiment 1, what was the value of M for the metal plate used in the setup? The equation in the passage and the results of experiment 1. What was... so it must be this. K is E minus M. So I'm going to try to use, I don't know, one of these. Let's see. If K is E minus M, then 0.4 is 2.6 minus M. And if you subtract the 2.6 from both sides, you're looking at negative 2.2 equals negative M. So M is 2.2. Yeah. The cutoff frequency for a particular metal is the lowest frequency of light at which electrons are ejected from the metal. Based on the results of experiment 1, the cutoff frequency for the metal plate was the lowest frequency of light at which electrons are ejected for experiment 1. Well, I'm guessing it has to do with this not applicable. Let's see. The lowest for which they are ejected. Oh, I see. Now, looking back at the words, right, the maximum kinetic energy of the ejected electron K is the difference between. But if they say not applicable, so that's implying that there was no ejected electrons. So the answer must be somewhere between here and here, somewhere between 5.2 and 5.6 times 10 to the 14th. 5.2 and 5.6. Yeah, it must be this. Yes. Okay. The relationship between E and the frequency of light is given by E equals HF, sure, where H is Planck's constant and F is the frequency of light. Based on the data for green light in table 1, which following expression could be used to determine the value of H. Green light in table 1 is 5.6 times 10 to the 14. So if I set this up as this is 5.6 times 10 to the 14. And then you're looking for H, and E is what it says it is up here, right? Isn't E this? Is 2.31 in this case. So wouldn't H be just that over that, right? It's 2.31 over that entity. 2.31 over 5.6 times 10 to the 14. Yeah, it's J. Where are we for time? At 38:18. Okay, that's actually really interesting. So according to the old timing for the standard format for the ACT, we would have been over by 3 or 3.5 minutes. But according to the new format, even with me explaining it, and I know I didn't do a perfect job, but stumbling through it well enough to get the right answers, I finished about 1.5 minutes or maybe 2 minutes ahead. So hopefully for some of you guys looking forward to the enhanced ACT, that's actually good news. That extra 5 minutes, which is an extra 1/7 of the total time that you have, that is a meaningful, significant addition that should give you just a little bit more flexibility. Again, still takes a lot of focus if you want to finish within the time, but it does help enormously. I'm happy about that.